In this lab, we're going to separate two liquids that have different boiling points using two kinds of distillation. In simple distillation, we're going to use these 10 items. First, use a cylinder to measure 1 milliliter of each liquid. To the conical vial, pour the liquid first and then add the spin vane. When you set up the system, build these items in this order. Make sure the Hikma still head has a cap. Here we have Claisen adapter, Hikma still head, and conical vial with the spin vane and liquids. Once you set up, turn on the stir and heat dials between 4 and 5. When you heat up, make sure the conical vial touches the hot plate. You need to make sure you don't heat too much because it sometimes forms bubbles around the neck and that can contaminate the pure sample on the top. So if you see overboiling, reduce the heat. When you collect the sample, open the cap of Hikma still head. Use a pipette to collect the sample into a screw cap vial. You will have a higher percentage of the lower boiling point liquid in the Hikma still head. Transfer this to a screw cap vial. The conical vial contains mostly the higher boiling point liquid. Save both liquid samples for later. After collecting about 1 milliliter, turn off the stir and heat dials. In fractional distillation, you're going to use these 13 items. This is how you prepare reflux condenser. Put the still wool into a reflux condenser and squeeze it using a copper rod. Do not use too much still wool. The reason we use still wool is to provide a surface for the vapor to condense and re-evaporate. This will increase the number of theoretical distillation plates and increase the purity of our distillate. Next, measure 1 milliliter of each liquid. For fractional distillation system, you build these items in this order. Again, make sure the Hikma still head has a cap. To the conical vial, pour the liquid first and add a spin vane. Now we have Claisen adapter, Hikma still head, reflux condenser with still wool, and conical vial with a spin vane and liquids. And turn on the stir and heat dials between 4 and 5. Again, make sure the conical vial touches the hot plate. Also, make sure you don't heat up too much. To collect the sample, open the cap of the Hikma still head and use a pipette to collect the sample into a screw cap vial, just like you did in a simple distillation. Save both liquids in the screw cap vial and the conical vial. After collecting about 1 milliliter, turn off the stir and the heat dials.
The plate and glassware after lab will be hot, so make sure to handle them carefully. Now I'm going to show you how to take a sample on the refractometer. We suggest you to practice using the refractometer with distilled water so that you have some experience before placing your sample. Organic samples evaporate quickly, and if you are uncomfortable with the refractometer, you might lose all your distillate. You're going to open up the prism. Then you're going to put your sample on the base of the prism. Just a couple drops will do. Remember to save some of your sample for your IR. Then close your prism, turn on the light, and bring the base of the light until it touches the prism. Now you're ready to look through the eyepiece. While looking through the eyepiece, adjust the focus knob until the horizon is directly on the X. This is what you should see when you first look into the refractometer. Notice how the horizon is not lined up with the cross of the X. Be sure to adjust your refractometer so the cross of the X and the horizon line up. If you need help adjusting or cannot find the horizon, your lab TA or instructor can help you. Once you have the horizon lined up, press read. Remember to clean the refractometer when you're done. Either before or after you use your refractometer, make sure to get an IR of both your high and low boiling point samples. Gathering multiple forms of data allows you to be more confident that your sample is pure. If you forgot how to take an IR, the instructions are right next to the machine. In order to figure out the percent of your low boiling point liquid on the samples you took from your distillation, we are going to use Excel to plot these two data points. We need the equation of the line of the pure samples to find out how well our distillation went. Note that the refractive index for the pure samples are provided in the lab instruction. Let's say that the refractive index of your pure high boiling point liquid is 1.496. And obviously, it has 0% low boiling point liquid. The pure low boiling point liquid has a 1.375 refractive index, and we have 100% of this liquid. Then you graph these 2 points. Here we have our pure low boiling point and our pure high boiling point liquids. We have to fit a line and click on the option to see the equation of the line. We do this by selecting the graph and then going to Chart Design tab. On the top left side, click on the Add Chart Element button and then select Linear Trend Line. Once you have the line, right-click on the line and select Format Trend Line. Click on Display Equation on Chart. Once you have your refractive index values from the refractometer readings, you are going to plug those numbers in for your Y and solve for X. X is going to tell you the percent low boiling point liquid that is in your sample. You do this for both of your distillates, and you can get how pure your sample was based on the actual pure samples of liquids.